Howdy, y'all. Yes, I know, showing my Texan side today. But guys, today we are starting Unit 3, Section 1. And guys, we're going to talk about identifying parallel lines and skew lines and perpendicular lines, along with identifying some angle relationships that are created with intersecting lines in a transversal. So again, some of those vocabulary terms are new to you guys. Some of you already know, right? So let's go take a look and see what you know and what you don't know. All right, let's go take a look. So first and foremost, guys, let's look at parallel lines. Okay, parallel lines. Most of you are very familiar with parallel lines. Okay, so as you guys can recall, okay, they are two lines or line segments. They could be line segments that do not intersect. They're never, ever, ever going to intersect. Okay, now something else. They must be coplanar. Okay, do you guys remember what coplanar means? Okay, let's see. Coplanar means that they're on the same plane, right? So they must be on the same plane. Now, we're going to denote parallel lines by using this notation right here. This notation. That means that line segment AB is parallel to line segment CD. Okay, that's what that little symbol means. Okay, and I'll just write it out here a little bit bigger. All it is a segment that looks like that. Okay, or if I draw in what they look like, okay, I would put those in between the names of my line segments. Okay, now, when you're looking actually on a picture, what tells you if the line segments or the lines are parallel are these symbols right here, those arrows. Okay, now arrows are different than congruency marks. Arrows symbolize parallelism. Okay, it doesn't tell me whether or not they're congruent. It just says that they're parallel. All right, so I want to show you guys, okay, we're going to come over here and I want you guys to look at this, this box over here. And I'm going to highlight, okay, some parallel lines. And we're going to be identifying these in the assignment, okay? So it says that line segment AB, which is right up here, is parallel to line segment CD, which is right here. Well, now, on this particular box or rectangular prism, guys, both of those lines are on the front side, and that is a plane. That front side represents a plane. Okay, now I have a question for you guys. Let's see what you guys think. Okay, y'all ready? Is line segment AB, is it parallel to line segment GH? What do you guys think? Okay, yes, they are parallel, because I want you guys to imagine this, and you're going to be imagining this. Can you imagine there actually is an invisible plane that goes diagonal through that box? So really, do you guys see what I just drew in? I just drew in a flat surface. So yes, line segment AB and GH are also parallel because I can draw in that imaginary plane. Okay, all right. So there's parallel lines. Now again, most of you guys knew this, but I want you guys to make sure that you understand this symbol for parallelism, okay, that notation, okay, and what's on the lines. All right, let's go take a look at what are skew lines, okay? Most of you might have heard that word before, but not really know what it means. All right, skew lines. Guys, skew lines are two lines that do not intersect. They will never, ever, ever intersect. Okay, and notice here, they must not be coplanar. Okay, well, if they're not coplanar, that means that they're also not parallel. And you should probably write this down. Okay, skew lines are also not parallel. Okay, now, there's not a notation for skew. We just write out the word skew. So if you see right here, it says that line segment AB is skew to line segment FH. Okay, so guys, let's go back up to our picture right up here. And let's highlight that. All right, let me erase our other highlights. Okay, so let's see. Line segment AB right here is skew to line segment FH, and that is back there. Okay, so I want you guys to look. They're not going to intersect. Even if they kept on going and going and going, they're not going to intersect. Okay, and they're not on the same plane. One is like AB. Okay, if you guys notice, AB is kind of on this front plane and on this top plane, and FH is on this side plane or on the back. So those are never going to intersect. And they're not parallel, are they? Okay, so there's an example of what skew lines look like. Okay, all right, last one that we're going to do, okay, is perpendicular. Okay, so perpendicular. Most of you are very familiar with perpendicular lines. Okay, so let's just go and look at this one more time. Perpendicular are two lines or line segments that intersect at a 90-degree angle. Now, some of you may know this notation, others of you not so much. Do you guys see this little symbol right there? It's an upside down T. That means that's the notation for line segment PQ is perpendicular to RS. Okay, and as we've already talked about before, the box is also a symbol on a picture for perpendicularity. So this upside down T means perpendicular. Okay, so let's go back up to our picture. This says line segment PQ is perpendicular to RS. Well, there's not a PQ and a RS right there, but there is right here in this picture. Okay, line segment PQ is perpendicular to RS. Okay, all right, now, ladies and gents, drum roll please. Right now, okay, we're going to jump into transversals. And before we do that, real quick, I want to point out right here, parallel planes. Guys, if I can have parallel lines, I can also have parallel planes. They're planes that are never going to intersect. And guess what? I can also have perpendicular planes, right, that intersect at a 90-degree angle. Okay, but the reason why we did the drum roll is for transversal. Oh, let me do that a little bit better. Oh my gosh. You guys, I think I need some more chocolate. I still need more chocolate. Okay, they say third time's a charm, right guys? Okay, transversal right here. There we go, Miss Smith. Good job. All right, a transversal. Guys, the definition of that is it is a line that intersects two or more coplanar lines. So over here in the picture, this line right here is our transversal because it intersects two coplanar lines. Notice it intersects both of those lines. Okay, so these lines right here, okay, those are the coplanar lines, and I'm going to abbreviate coplanar lines. So a transversal intersects two or more coplanar lines. Hey guys, it could actually intersect a third line as well. That's a transversal as well, or the transversal still intersects that third line. Okay, all right. Couple different terms and definitions here that we just dealt with, but we have more. Y'all ever see that commercial? But wait, there's more, right? Okay, we're going to go on to page 2. And when we go down and look at page 2, guys, we're going to talk about some vocabulary that is different parts of angle relationships. You're going to need to memorize these. You're going to need to use these all year long. Okay, so let's go and look at page 2. And let's finish the vocabulary. Okay, here we go. Page 2 of the notes. I know there's a lot more notes in this section. That's because there's a lot of vocabulary. Okay, but let's just keep on trekking through. Okay, so I want to point out some other vocabulary terms. And before I do that, I want you guys to notice, look right here. Here is a green line, okay, that I just highlighted. Can you guys tell me, what would I refer to that line as? And we just talked about it. What kind of line is that? Okay, hopefully you guys said, hey, Miss Smith, this line right here, that is our transversal. right? Okay, transversal, and I'm going to abbreviate. That's our transversal. Okay, now there are certain angle relationships that are created when a transversal intersects two or more other lines. And I want you guys to notice this. Right here, it says that angles 1 and 2 are outside of the lines. Okay, angles 1 and 2 are outside of the lines. So that means that it's not, if you guys notice, they're not in between the lines. They're on the outside part of the lines, aren't they? Okay, now, ladies and gents, another word for outside the lines is exterior. Okay, exterior. They are exterior of the lines. Okay, oh, well look, we've also got 7 and 8 down here. 7 and 8 are also outside the lines, aren't they? So those are also exterior, okay, to the lines. Okay, well, then if we look at this, it says 3, 4, 5, and 6. So 3, 4, 5, and 6. Those are between the lines. So if you guys notice, both of those are in between the lines, and those are in between the lines. Well, another word for between, in between the lines, is interior. Okay, they're on the interior of the lines. Okay, now I point out those vocabulary terms because that's going to help us to determine the angle relationships. All right, let's go take a look. So right here, very first one says corresponding angles. Okay, corresponding angles are two angles. Okay, oh, let me point this out real quick. Do you guys see that abbreviation, COR? That's how you can abbreviate corresponding angles, by COR. Okay, they are two angles that have corresponding positions with respect to the lines and the transversal. And they must touch the same transversal. So what does that mean? Well, this is what that means. If you guys notice, okay, angle 1 and angle 5, okay, are both, if I look at where the lines intersect, angles 1 and 5 are both up and to the right, otherwise known as the northwest corner, aren't they? So they're both in the northwest corner, part of their respective positions, okay? So where they intersect the transversal. All right, and then the same thing goes, if you guys look, 2 and 6, okay? 2 is up here, which would be the northeast corner. 6 is up here, which would also be the northeast corner. So those are also corresponding angles, okay? And we have the same thing going on for angle 3 and angle 7. They're down there in the southeast corner. And, oh, wait a minute, correct me. That's the southwest corner. And then 4 and 8 down here those are in the southeast corner, right? So when you talk about corresponding locations, literally you're talking about where are they on that intersection, okay? So now let's move down, okay? And we're going to talk about alternate interior angles. Alternate interior angles are abbreviated, okay, with this right here, AI. It's their initials, right? AI, alternate interior. Now, notice, guys, right here, alternate interior angles are two angles that are between the two lines, but they're on opposite sides of the transversal. Okay, so if they're between the lines, that means they're on the interior, hence the name alternate interior, right? And if they're on opposite sides, it means that they alternate across the transversal, which, get it? Alternate interior? Okay, that's where the name comes from. Okay, so we're talking about angles that are on the interior, but they alternate across the transversal. So if you guys look, and I'll actually highlight, I've got angle 3 and angle 6. Those angles are in between the lines, but they are on opposite sides of the transversal, okay? It's like they crossed the street, didn't they? Okay, they went across the street. So 3 and 6 are alternate interior angles. Well, the same thing goes, and I'm going to point to it, 4 and 5 are also alternate interior because I've got one up here and then I go across the transversal and the other one's down there. But they're inside the lines. Now, I'm going to show you guys a neat little trick for identifying alternate interior angles. Okay? I call it the Z method. Okay? So I can draw the letter Z by starting on one line, go down the transversal, and go the opposite way on the other line. And if I can draw in the Z method, then I can identify alternate interior angles. So watch this. I start up here on this line. I go down the transversal, go the opposite direction on the other line. Hey guys, if you will look at the angles that are in the bend of that Z, so right here and right here, hey, angles 4 and 5 are alternate interior angles. Now, some of you are saying, but wait a minute, Miss Smith, that's not a Z, that's backwards. It's okay. You can draw the Z either way in order to find the alternate interior angles. So the method that I just showed you, again, okay, is called the Z method. Okay, that is a way to help you identify alternate interior angles. Okay, let's go on down now and let's look at alternate exterior angles. Okay, well, if they're alternate exterior angles, it means that they're going to be outside the lines, right? And by the way, look at the way that we abbreviate it, AE for alternate exterior. So these guys are outside the line, hence the word exterior, okay? And on opposite sides of the transversal, hence the word alternate for alternating across, okay? Now, this one, we're only looking at the exterior angles. So we're only looking at 1 and 2 and 7 and 8. We don't even need to look at the ones that are inside. We're not dealing with those right now. We're looking at alternate exterior. Okay, so alternate exterior. Angle 1 is exterior, it's outside the line. But now I want to go down to the other angles that are outside the line and find the one that is on the opposite side of the transversal, and that is angle 8. Okay, and then your other set, you have angle 2 and angle 7. Notice all of those angles are outside the lines, right? They're outside the lines and they alternate across the transversal. All right, let's shift gears for just a second. We're now going to look at what we call consecutive interior angles. All right, the reason why we're shifting gears is because consecutive interior angles, abbreviated CI, are two angles that are between the two lines, so it's on the interior, but they're on the same side of the transversal. Okay, so let's take a look at this. Angles, they have to be inside. So let's start with angle 3 right here. And if I say which angle is consecutive interior to angle 3, well, it has to be on the same side of the transversal, so it has to be angle 5, right? So this time, they're not going across the transversal. They're not going across the street, if you will. They're staying on the same side of the street. And then we have angles 4 and 6 that are also consecutive interior angles. They're inside the lines and they're on the same side of the transversal. Okay, guys, that was a lot of vocabulary, a lot. Now, my hope is that you guys have constructed and put together your flip chart for chapter 3 that will help you to remember all these angle relationships, but yes, you're going to have to memorize them, okay? But before you have to memorize them, we're going to practice them. Okay, you'll be able to use your flip chart. But we're going to start off first. We're going to do stuff a little bit differently this time. Hey, we've actually done this before. We're going to go do one of the algebra review problems before we dive into the rest of the assignment. All right, guys, we're going to go down and take a look at letter C. Letter C as in Charlie. All right, I'll see you down there in just a second. Okay, here we are, letter C. Now, guys, this one, Some of you may recognize this. Some of you may not recognize this. Okay, there are a couple of different ways that you can work out this particular problem. Some of you may have learned this as the FOIL method. You use the FOIL method. Some of you, okay, learned it as the X method. Okay, what I'm going to show you is actually what you're going to be using in moving forward, especially when you guys go on to Algebra 2, and that's called double distribution. So let's take a look at that. Okay, double distribution means that double means 2, distribute means that you're going to multiply out to both terms. Okay, so when we do double distribution, guys, we're going to distribute twice. Now, the way I do it is I start by distributing the first term in our parentheses. By covering up, I'm going to cover up this guy, covering him up. And then we're going to distribute. All right, we're going to distribute the x. So I do x times x. Okay, well, guys, x times x is x squared, right? And then I distribute and I do x times -4, which is -4x. Okay, there was my first time to distribute. Now I am going to cover up the first term. I'm going to cover that one up. I already distributed that one. I don't need that one anymore. Now I'm going to do the second distribution. So now I distribute the second term. So 1 times x is x, and 1 times -4 is -4. Okay, and then we're going to go and set that equal to the -3x that is already there. Okay, so guys, what we just did right there is double distribution. Okay, now we're going to solve for x. So that means, next thing, we combine our like terms. Well, I only have one value that's x squared, so I don't need to do anything with that. Okay, I've got an x value right here and an x value right here. Okay, so that means that I'm going to have x squared was just all by itself. -4x plus x. Hey guys, that gives me a -3x. And then, well, guys, the -4, that's the only constant that I have. So that just stays like it is. Okay, nothing on the right-hand side to combine. Okay, wait a minute. We have an x on the right-hand side and an x on the right-hand side. We need to combine those. So when I combine those, I add 3x to either side. Well, when I add 3x to either side, guys, look what happens. I end up with x squared minus 4 equals, well, -3x plus 3x equals 0. So how do I solve that now? All right, well, let me scroll down and we're going to take a look. So the way that we solve it, we're going to move, we got to still get the x all by itself. So move the -4 to the other side. So you have x squared equals 4. Okay, and then remember, in order to get to x instead of x squared, guys, we're going to take the square root, if I could draw correctly, the square root of both sides. And when we take the square root of x squared, it gives me x. And then when we take the square root of 4, hey guys, I don't know if you remember this, but when you take the square root of a number, it can either be positive or negative, right? So this is actually either a positive or negative. The square root of 4 is 2 because, okay, guys, not only, let me explain why this is, because 2 times 2 equals 4, right? That's what 2 squared means. And -2 times -2 also equals positive 4. So it could be positive or negative, but up here it says that we want the positive value of x. So the positive value of x is 2. Okay. All right. Now, if you guys have questions on the double distribution, okay, be sure to ask your teacher during class. Okay, we'll work out some more with you. And yes, guys, you are going to see these occasionally throughout the year. All right, we're going to go down next, and guys, we're going to work out one of the parts of question number 5. So go to question number 5. All right, so we're down here at question number 5. Now, question number 5, the instructions say, okay, use the picture of the rectangular prism and list all, notice it says all line segments that fit the given description. And it says that to make sure that you use the correct symbols, that your symbols are accurate. Okay, so let's look at what letter C. I'm going to do letter C with you guys. Okay, letter C says we want to list all line segments that are skew to line segment FH. Well, FH, you guys, is down here. Now, if you're a highlighting type of person, you might highlight, right? So, skew. Let's recall, okay? Skew lines have what properties? Okay, hopefully you said skew lines never intersect, they're not coplanar, and they're not parallel, right? Okay, so we want to look for other lines that are not going to intersect. So it can't be, if it's not going to intersect, it's not going to be EF, and it can't be GH because those both intersect. Oh, well, so do BF and DH. It can't be any of those, so those don't work. Okay, what about BD? Is line segment BD, is that skew to FH? No, it's not. BD is parallel. Remember, it can't be parallel. Okay, what about line segment AB? Do you guys think that line segment AB is skew to FH? Yeah, it sure is. Good job. All right, so I'm going to highlight this up here. So line segment AB is skew. It's on a different plane. It's never going to intersect, and they're not parallel. Okay, well, how do I write that out? Okay, guys, remember, your symbols matter. So if I were to say line segment AB, you can't just put AB like that. You got to put the symbol line segment over the top of it. Line segment AB. All right, well, let's see. If I look at this, what do you guys think? Do you think that line segment CD is skew to FH? What do you think? Yep, it sure is. It will never intersect, and it is not on the same plane, right? So let me get the good highlight. There we go. Okay, it's never going to intersect. It's not on the same plane. It's not parallel. So sure enough, yep, line segment, I'm going to put a comma, and I'm going to say line segment CD will also work. All right, so guys, are there any others? What do you guys think? Let's see here. Let's see. I want you guys to answer me this, okay? What about line segment CG? Will that be skew to FH? Okay, what about AE? Will that be skew to FH? Okay, what about EG? Is that skew to FH? All right, what about AC? Okay, so let's see how you did. All right, so guys, CG and AE, those are both skew, okay, to FH. So let's highlight those. Those are both skew because they're not on the same plane. They're never going to intersect, and they're not parallel. But guys, AC and EG, they're parallel to FH, so they can't be skew. Okay, they can't be skew. Okay, so I'll go ahead and write those other two line segments down. So line segment AE and line segment CG. Okay, those are the ones that are skew. Okay, all right, now I'm going to let you guys work out the rest of this problem. Okay, and remember, guys, you need to test all of the line segments to see if they are parallel or perpendicular, or if they intersect. Whatever the question asks you, make sure you check all the line segments. Okay, we're going to go down to number 6, and I'm going to help you guys get started on question number 6. All right, I'll see you in just a second. Hello again. All right, so guys, on question number 6, it says that we're going to use the picture to identify all pairs of angles of the given type. So those are those angle relationships that we just talked about, plus the angle relationships from chapter 1. Okay, so let's take a look at this, and I'm going to help you guys by helping you to identify at least one pair, okay, of angle relationships. So the very first one that it asks us for is corresponding. So remember, corresponding angles are in the same location with respect to the intersection. So if you guys look over here, I've got angle 1 is in that top corner, which means that if corresponding would be 5, right? Because both of those are in the top location. So I would write that. I would put angle 1 and angle 5. Okay, so that's how you name the angle relationships. Now, I'm going to give you guys a hint. Okay, there are a total of 4 corresponding angles in this particular picture. Okay, so you guys can find those. All right, next it says to find the alternate interior angles. So remember, alternate means inside. So if I start with angle 4 and I say, okay, you know what, that's an interior angle. Okay, well, which angle is alternate? That would be angle 6. Okay, so angle 4 and angle 6 are alternate interior angles. And just as a hint, there's 2 pairs of alternate interior angles on this particular picture. Okay, consecutive interior. All right, that interior, they're going to be in between the lines. Okay, so let's go. Let's start with angle 4 again. Okay, angle 4, and I have to say, well, which angle is a consecutive interior angle to angle 4? You know what? Why don't you guys try this? Consecutive interior. Which angle do you think, okay, out of 3, 5, and 6 that are on the interior is consecutive to angle 4? All right, hopefully you guys answered that it is angle 5, right? Okay, angle 4 and angle 5, they're on the same side of the transversal and they're on the inside. Okay, all right, I'm not giving you any more hints. You guys get to figure out how many more pairs there are. All right, now alternate exterior angles. Okay, so remember, exterior means on the outside. So I'm gonna, you know what, I'm gonna come over here and I'm gonna do angle 2 this time. That's on the outside of the lines, right? And alternating means that it's going across the transversal. So, hey guys, you give this a shot. So, which one of the other exterior angles do you think is the alternate exterior to angle 2? All right, hopefully you said angle 8, right? So, angle 2 and angle 8. Okay, notice that they are on opposite sides or alternating sides of the transversal, and they're both outside the lines. Okay, here we go. We're going to keep on going. And again, I'm not going to tell you guys how many more problems or how many more relationships there are. You guys are going to have to figure it out from here on out. Vertical angles. VA, vertical angles. Hey guys, this is from chapter 1, right? All right, vertical angles. It doesn't tell us if they're inside or outside. Vertical angles are created by the X, by intersecting lines. So I'm going to go down here to angle 6. Okay, and we're going to start with angle 6. And I'm going to ask you guys, which angle up there is vertical to angle 6? Hopefully you guys said, hey, Miss Smith, it's angle 8, right? Because when I'm looking for, okay, vertical angles, I just have to look at one intersection. I don't even worry with this intersection. When I'm dealing with vertical angles are only at one intersection. Those 5, that 6 and that 8, rather, are just down there on one part of the intersection. It doesn't have to be on 2 different intersections. Okay? All right. Well, now the next one, and I know that's way down at the bottom of your screen, is a linear pair. Okay, linear pair. Now remember, linear pairs, those are from Unit 1 as well. Okay, so linear pairs. Do you guys remember linear pairs? Okay, let's see. Guys, which angle, okay, which angle is a linear pair to angle number 3? What do you guys think? All right, let's see if you guys were on track. Okay, angle 3 actually has 2 different possibilities. Okay, so angle 3 is a linear pair to angle 2. right here. That is one possibility, okay? Or angle 3 is also a linear pair over here to angle 4. Because, guys, both of those angles with angle 3 make a straight line. So if you guys notice, okay, we've got angles 3 and 2 and angles 3 and 4 are both linear pairs. All right, don't forget, you got to list all of them when you guys are listing these out. All right, now, last but not least, we have the no relationship angles. Okay, so, guys, no relationship. That means that, okay, let me come up here and talk to you for just a second. No relationship means this. One is that they do not touch the same transversal, or two, they're not any of the other relationships that we've talked about. They're not corresponding, they're not alternate interior, they're not alternate exterior, they're not consecutive interior, they're not vertical angles, they're not linear pairs. There's no direct relationship. So let me show you what that looks like. So if I start up here, and you know what, I'm going to start up here with angle 5. If I start up here with angle 5 and I'm going to test out, let's see, angle 5 and angle 1, nope, those are corresponding. Those are in the same location. All right, angle 5 and angle 2. Oh, well, angle 2 is on the outside, angle 5 is on the inside, and they're not corresponding. Hey guys, we have a winner, right? Angle 5 and angle 2 have no direct relationship, okay? So one is exterior, one is interior. They're not corresponding. They're not vertical. They're not linear pairs. No relationship, okay? And again, there's more, okay? But I'm not going to tell you how many for you to find. All right. Now, guys, I know that this video is longer than normal. That's because we have a lot of information, okay? So when we work out this assignment in class, make sure that you come to class with your assembled Chapter 3 flip chart and your assignment so that you are rip-roaring and ready to go. Finish it up, ask questions, and bust out that code breaker. All right, see you guys in class. Adios.